Hello friends, I'm Bob. In this video I will be showing you the solution to the integration of sine inverse x over 2 dx. But before I do so, if you guys like the solution, help me press the thumbs up icon below this video. To solve this particular problem, the very first step that we will need to do is to apply the integration by parts technique. The integration by parts formula tells us that I define a term as u and the other term as dv. So this is equals to the uv subtracting away the integration of v du, in which to find my v I would integrate dv, and to find my du I would differentiate u. For this particular problem, we will first express the integral of sine inverse x over 2 as the integral of 1 times sine inverse x over 2. So that we have two terms, and then we can apply the integration by parts technique. Next, we will let u be equals to sine inverse x over 2 and my dv be equals to dx. To find my du, I differentiate u with respect to x. This gives me 1 over square root 1 minus x over 2 square times differentiating x over 2, we get half. So this is equals to 1 over the 2 square root of 1 minus bracket x over 2 square. And to find my du, I just multiply both sides by dx. I get basically just this. To find my v or integrate dx, this gives me x. I now have my dv, v, u, du. I can apply the integration by parts formula. To move on to the next step, I get the following. My u is sine inverse x over 2. My v is x, subtracting away the integral of v, which is x. And then my du is 1 over 2 square root of 1 minus x over 2 square dx. And I further simplify the integral term. I get the following, which is the integral of x over 2 square root of 1 minus x over 2 square dx. I next apply this particular integration technique, which is if I were to integrate the differentiator function fx to the power of n dx. So this is equals to fx to the power of n plus 1 over n plus 1 plus c. In order to apply the integration technique, I first need to identify what is my fx, my n, and my f prime x. So first things first, my fx is basically just 1 minus x over 2 square. And to find my f prime x, I differentiate fx. I get the following, which is negative 2 x over 2. Differentiating x over 2, I get just half. And this is basically just equals to x over 2. My n is negative half. Before I apply this particular formula, the first thing I need to do is I need to re-express the second term, which is the integral term. I get the following, which is the integral of negative x over 2. And I bring up my square root, I get 1 minus x over 2 squared to the power of negative half dx. Next, I apply the integration technique. I identify what is my f prime x, which is negative x over 2. And this part itself is my fx. This is my n. And hence, I apply the integration technique. I derive the following. My fx is 1 minus x over 2 square, the whole thing to the power of n plus 1, which is half, divided by half. So this is equals to x sine inverse x over 2. And I bring the half out into the numerator, I get 2 times. Within the square bracket, I factorize 1/4. I get 4 minus x squared to the power of half. Then after that, I take the 1/4 out of the square root. I basically get half. And I multiply by 2. I basically have just 4 minus x squared to the power of half. In other words, I can just re-express this as square root of 4 minus x squared. This is the final answer to the integration of sine inverse x over 2 dx, which is x sine inverse x over 2 plus square root 4 minus x squared plus c. If you guys like the solution, press the thumbs up icon and do consider to subscribe for more integration problems. My name is Bob. Thank you guys for your support and I will see you in the next video. Goodbye guys.